Hello friends and my dear students, I hope you are all well and your studies are also going on well. In this video, I'm starting the next chapter which is lines and angles. This is part 1 video of the chapter of lines and angles. In this part 1 video, we will understand and discuss about the basics of angles and its properties. Particularly, we will discuss about the supplementary and complementary angles. We will also discuss a linear pair of angles and vertically opposite angles. And finally, we will solve some problems from exercise 13. So this video is part of the playlist CBSE Mathematics for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or if you are not yet subscribed, I will highly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my rough notes prepared on the left hand side, and I hope you can see it. Okay, so I have the rough notes prepared on the left hand side, and on the right hand side I will discuss the concepts of the properties of angles, and finally we'll solve the problems from exercise 13. So let's get started. So properties of triangles, I have pointed out some properties. There are approximately how many properties? There are 9 properties that I will discuss on angles. In your class 6 previous class, you have already studied a brief. We have already studied the preliminary idea. You have preliminary idea of what is a line, what is a ray, what is a line segment, concurrent lines, parallel lines, and perhaps also angles. I'm not sure, but anyway. So, what are the properties of angles? The first one says that if there are two angles, if two angles A and B are two angles, and if their sum of the two angles A and B is 180 degree, then we say that the angle A and B are said to be supplementary angles. Now, angle, you know that what is meant by angle? Angle is nothing but we have two rays. Let's say we have two rays OA, and we have another ray, let's say OB, and these are rays, and they both intersect at the point O. That is, O is the common point, and so we say that this angle, this is the angle. The angle produced by the ray OA and OB intersecting at the point O is the angle AOB, is the angle AOB, or we can also say BOA. So this is an angle. So if two angles, this kind of two angles, their sum is 180 degree, then we say that the two angles A and B are said to be supplementary angles, or we also say they are supplement to each other. Similarly, if two angles, the sum of two angles is 90 degree, we say that they are complementary angles, or one angle is complement of the other angle. So if angle A plus angle B is 90 degree, we say that angle A and B are complementary angles, or angle A is complement to B, or angle B is complement to A. So this is pretty straightforward. These are just definitions, and there is nothing to really understand about it. Just a definition. Now, what are adjacent angles? Now, adjacent angles are angles having a common vertex and arm, with other arms lying on the opposite sides of the common arm. Now, in the example you see, let's say, now what is an arm? This on the right hand side, this angle, the angle AOB or the angle BOA, it has arms OA and OB. The rays OA and the OB are called the arms, and they have a common point, that is O. Now, what are adjacent angles? Adjacent angles are angles having a common vertex and arm. So in the figure, you can see the common arm is OA, and if you consider common arm is OA, and if you consider the angle AOB and AOE. So let's say we have this, we have what are adjacent angles. So let's say we have, it says that adjacent angles are angles that have a common vertex and arm. Common vertex and arm with other arms lying on the opposite sides of the common arm. Now, what is exactly meant by opposite sides of the common arm? Let's say we have a common arm. This is a common arm. Let's say OA. This is a ray. This is a common arm, and let's say the two angles now. So this is a common arm, and the common point is O. Now one angle, let's say B, this OB. One angle is AOB. So one angle is AOB with the two arms OA and OB, and another angle, let's say we have OC. Now clearly the angles AOC, this is angle AOC, this is angle AOC, and this one is angle AOB. Now the angle AOC and the angle AOB is formed by the arms OA and OB, and the angle AOC is formed by the arms OC and OA. So clearly OA is the common arm and O is the common point. Now it also says that the angle AOB and AOC will be adjacent angles if the other arm means over here, what are the other arms? The other arms, the common arms is OA. So the other arms are OC and OB. OC and OB are the other arms. They must lie on the opposite sides of the common arm OA. Now what does it mean? Now it means nothing. If you extend the ray OA on the opposite sides, like if you create a line, let's say I create a line, I hope it is looking like a line. Let's say AD. Let's say this is D. So let's say, so AD is the line I created from the ray OA. That is the ray OA. The point A will extend endlessly. If I now convert this ray OA to a line, that is it will also extend to the on the other end also. That is, we have another ray OD. So AD is a line. AD is now a line passing through the point O. So now the other arms, that is OC and OB, should lie on the opposite, on the different sides of the line AD. Now this is what are the different sides? Now clearly you can see that arm OC is lying to the left hand side, or the left and upper side of the line AD, whereas the arm OB is lying on the right hand side and below the line AD. So this is why they are on opposite sides of the line AD, or we can also say lying to the opposite side of the arm OA. Now clearly if I draw an arm, let's say if I draw another arm, let's say OE. Now OE and OB, the arms OE and OB are lying on the same side of the common arm OA. So angle AOB and angle AOC are adjacent, but angle AOB and angle AOE are not adjacent because they lie on the same side of the common arm OA. The arms OB and OE is lying on the same side of the common arm OA. So this is the definition of the adjacent angles. So adjacent angles are angles where they have a common arm and the common point, and the other two arms must lie on the opposite sides of the common arm. Okay, let's see what is now. You can pause the video and take a screenshot of my notes if you think it will be beneficial for you as a future reference. So you can take the notes, take a screenshot. So these are some examples of angles which are adjacent and angles which are not adjacent based on this diagram. Now, what are next property is property number 4, a linear pair of angles. What are linear pair of angles? Linear pair of angles are two adjacent angles where the non-common arms form two opposite rays. Now, they are also linear pair of angles are also adjacent angles, but the restriction is that the non-common arms. So, the non-common arms will form two opposite rays. Now, will form two opposite rays. Now, two opposite rays means that they will form actually a straight line. So, let's say we have two opposite rays. So, the linear pair of angles are two adjacent angles where the non-common arms form two opposite rays. Okay. So, let's say the common arm be the ray OA. Let's say this is the common arm, and obviously both the angles will have a common point O. Now we have to how can we form a linear pair of angles with this OA as the common arm and O as the common point? So what we do is we know that we have the other two arms. The other two arms of the angles should be on the opposite sides of the common arm OA. So let's say I take an arm OB like this and take other arm B like this C. So we have the arms OA, OC and OB lying on the opposite sides of the common arm OA. So definitely angle AOC and angle AOB are adjacent angles, but the arms OC and OB are not forming any opposite rays. So if I want to make the ray OB and OC to form opposite rays, now what is opposite rays? Then what we have to do is we have to basically, now an opposite ray of OB is what? We have to extend OB to the other side. So we will have to make a ray like this. So this now OC is an ray which is opposite to ray OB. And so now the arms OC and OB are opposite rays, and the angles, this angle which is angle AOC and this angle which is angle AOB are linear pair of angles, Obviously they are adjacent angles because the arms OC and OB are on the opposite sides of the common arm OA, and above that the arms OC and OB are forming two opposite rays. That is, the ray OC and OB is forming a line. The BC is a line where the two end points B and C are they will stretch to endless distance. They will stretch endlessly. So now the angle AOC and AOB will be a linear pair of angles. Okay. So this is the definition of linear pair of angles. Now, so how do we actually form a linear pair of angles? So you can see adding any arm OC to given opposite rays OA and OB forms the linear pair of angles AOC and BOC with OC as the common arm. So definitely to form a linear pair of angles, you will need a line. That is, the two opposite rays will actually form a line. So you take two opposite rays. How do we form a linear pair of angles? I will form two opposite rays. Now, how will I form a two opposite rays? I will make a line. I will make a line, that is, which will both the ends have, both the end points will stretch endlessly, and let the opposite rays are OA and OB. Now, if I now from the point O, if I take any arm, you can take any arm, it does not matter. It should not lie on the line AB. So any arm that is not lying on the line AB. So AB is a line. We know that AB is a line, and OB and OA are opposite rays. So now if you take, so you have two opposite rays, that is OA and OB. Both the rays will actually form the line AB, and now from the point O, if you make any arm which is not lying on the line AB, let's say that arm be OC, then you will have two angles BOC, this angle BOC and the angle AOC, they will be linear pair of angles where the two angles have the common arm OC and the common point as O. Okay, I hope the linear pair of angles is clear. Now you can take a screenshot of my notes. I have some figures. Okay, now one thing to note that the sum of two linear pair of angles will always be 180 degree. So angle AOC plus angle BOC will be equal to 180 degree. So sum of any two linear pair of angles is always 180 degree. Always keep this thing in mind. Or you can say that a linear pair of angles are supplementary angles, or they are supplement to each other. Okay. Now point number 6 is just saying that a ray OC standing on a line AB forms a linear pair of angles. That is what I just explained. So on a line AB, and if you take a point O on the line and you create a ray OC, then that ray OC and the line AB will create two angles, angle BOC and angle AOC, which will be linear pair of angles. Okay, now point number 7 says that the sum of all angles formed on the same side of a line AB at a given point O is 180 degree. The sum of all angles formed on the same side of a line AB at a given point is 180 degree. Now, what does it mean by saying an angle is formed on the same side of a line AB? So let's say we have a line AB. So let's say this is the line AB, and let's say we have a point O on the line. So how do we make an angle? It says the sum of all angles formed on the same side of a line AB at a given point O is 180 degree. This means that to make an angle, so we have to consider all angles only at one specific side, either to the up for this angle, since this straight line since this line is horizontal, we can consider the two sides as the upper side or the lower side, above the line or below the line. If the line was vertical, we would have said the one side is to the left and the other side is to the right. Now for this line which is horizontal, so in the let's consider the side above the line. So if you want to make an angle, what you do is you drop a ray at the point O. So let's say I am dropping a ray at the point O, OC. Now this ray OC is forming has formed two angles. This is angle BOC and this is angle AOC. So obviously we will have since they are linear pair of angles, AOC plus angle BOC equals 180 degree. Now, so we have formed two angles on the line AB at the point O. So let's make a few more angles. The idea is that no matter how many angles we make on a line, the sum of all those angles, all the angles has to be on one side of the line. The sum of all those angles will be 180 degree. This is the property. So we have this line. Let's take a point O. Let's say we drop two rays. One is OC, so that we have more angles. So we have OC, and let's say we have another ray OD. So how many angles are formed? This is one angle BOC. This is one angle COD, and this is another angle AOD. So we must have, the property says that angle AOD plus angle COD plus angle BOC will be equal to 180 degree. This is the property you must know. Okay. Now I hope it is clear what do we mean by multiple angles on one side of a line. So AB is the line. In the first example, AB is a line, and we have a ray. We dropped a ray OC at the point O on the line, so which created two angles, angle BOC and angle AOC, and their sum and obviously angle BOC and angle AOC are adjacent angles. Are linear pair of angles, so their sum will be 180 degree. The sum of linear pair of angles is always 180 degree. Now in the second example, we dropped two rays OC and OD at the point O on the line. Now it says that as per the properties, it created three angles: angle BOC, angle COD, and angle AOD. Now how come their sum is 180 degree? This is because we know that when the first ray was dropped OC, we know that when the first ray was dropped OC on the line, we know that angle BOC, that created two angles, angle BOC and angle AOC, and we know that from the definition of linear pair of angles, angle BOC plus angle AOC will be equal to 180 degree. Now when we dropped another ray OD at the same point O, what happened? The angle AOC got divided into two angles, AOD plus ACOD. The angle AOC got divided into two angles, angle AOD and angle COD. Now obviously since now from 1 and from 2, we can always say 1 and 2 implies in the 1, if we substitute angle AOC with angle AOD plus COD, we get angle BOC plus angle AOD plus angle COD equals 180 degree. So this is true for three angles. If you have more than three angles, you will see the same logic will apply, and the sum of all those angles on the one side of the line will be always be 180 degree. So in the figure, in the notes, you can see some. I have two diagrams. One forming some angles on the upper side of the line AB, and on the second diagram, some angles forming some angles on the lower half, on the lower side of the line AB. Point number 8, properties number 8 is that now the sum of all angles around the point is 360 degree. The sum of all angles around the point is 360 degree. Now what is this? What is an angle around the point? So we have a point, let's say O. Now if we want to make an angle at a point O, we need two arms. We need two arms, right? We need two arms. So let's say one arm be OA. Sorry, OA, and another arm be, let's say, any arbitrary arm, any B. So we got an angle. This angle got created, angle AOB. So this is an angle AOB is an angle around the point O. Now there is another angle. If you consider this angle, if you consider the outer angle, not outer angle, if you consider this angle, this is also an angle. This angle is also an angle around the point O. So this angle, let's say angle AOB, if we call it alpha, let's say, and this angle we call it beta, we will have alpha plus beta equals to 360 degree. So when we create an angle around the point O, we got actually two angles created around the point O. One is the angle AOB, inner angle AOB, and the outer one is the angle beta. Now let's say we create a few more angles. Let's say we have the point O, and we have the arm OA, and the arm OB, that is creating, let's say, this angle, let's say this be angle alpha. I mean, this angle is obviously AOB, but let's say we denote this angle with alpha. Now let's say I create another arm at the point O. Let's say this be C. So I have now created. Now what happened is, initially when the only alpha was there was actually two angles, alpha the inner angle and the outer one, this one. Alpha was there and this angle was there. Let's say this be beta. So alpha plus beta was 360 degree. Now when I created the ray OC, what happened is that the angle alpha actually got divided into two angles. This angle, let's say this be gamma, and this angle, let's say this be what to call this angle, M, whatever, M. So beta is now gamma plus M. I mean, I hope you can understand it visually. The angle, before drawing the ray OC, we have two angles. The angle alpha, which was created by the arms OA and AB, and there was the outer angle beta, and we had alpha plus beta equals to 360 degree. Now when I am creating another angle, let's say gamma, by adding the ray OC, that is gamma is actually the angle AOC, where gamma is actually the angle AOC. what happened is that the angle beta got divided into two angles. Beta got divided into two angles, AOC plus angle uh, COB. COB. So now we will have AOC. Now, so now we will have, we earlier had, so this is gamma plus M. Now it is similarly, I mean the concept is similar to the multiple angles on a straight line on the same side. So now we have, earlier we had alpha plus beta equals to 360 degree. Now we divided by adding another angle, another ray OC. We divided the angle beta into two angles, that is gamma plus M. This equals to 360 degree. So if we add more rays at the point O, it will create more angles, and the sum of all those angles will be 360 degree. So this is all about the properties of angles. There is one very important properties of angle, which is vertically opposite angles. Now what is vertically opposite angles? Now when two lines AB and CD intersecting at a point O, we have two lines and they intersect at a point O, then the two pairs of vertically opposite angles are formed. If you see the figure, we have the line AB and the line CD, they intersect at the point O. Then it is creating two vertically opposite angles, two pairs of vertically opposite angles. So one pair of opposite angles is the angle AOD and angle COB or BOC, and the other pair of opposite angles is the angle AOC and angle BOD. So angle AOC equals to angle BOD, since they are vertically opposite angles, and similarly the angle AOD is equal to angle BOC, as they are vertically opposite angles. So when we say two angles are vertically opposite angles, when two lines intersect lines, when two lines intersect at a point, then we have two pairs of vertically opposite angles are created. Now let's say we have an angle. So two angles are vertically opposite angles. What does we just explained the concept of vertically opposite angles with the fact that when two lines intersect at a point O, then two pairs of vertically opposite angles are created. But what is the actual properties of two vertically opposite angles? So let's say I have an angle will have a point O and two arms having the common end point O. Let's say I have this angle AOC. So AOC, this is the angle formed by the arms OA and OC at the point O. Now I have, let's say, another angle created at the point O only. Let's say this will be D, and let's say I have another angle formed by the arms OD and OE. So I have two angles AOC and AOD. Now are these angles vertically opposite angles? No, they are not. Now why the angle AOD and angle AOC are not vertically opposite angles? Because the property for the angle AOD and the angle COD to be vertically opposite angles, one property has to be met. First of all, they must have the common point. Both the angles must have the common point, that is the common point O, which is true. But the arms of the angles must form opposite rays, meaning the arm OD uh, the arm OD must be opposite to the arm OA, and the arm OE must be opposite to arm OC. So if we do that, let's say let me see if I can copy this. Now I want to make these two angles vertically opposite. How will I do it? I will have to make the arms of the angle AOC are OC and OA, and the arms of the angle AOD are OD and AE. The criteria is that the arms of the angles must form two opposite rays. So I have to adjust the arm OD to be a ray opposite to OA. So the ray OD has to be like this, has to be opposite to OA, and the ray OE has to be opposite to the ray OC. E. So now the arms OD and OA are opposite rays, and the arms OE and OC are opposite rays. So now the angle AOC and angle DOE are vertically opposite angles. Similarly, this is one pair of vertically opposite angles. Similarly, the other pair of vertically opposite angles are these two angles. So this is angle DOC, and this is angle AOE. So AOE, so angle AOC and angle DOE. This is one pair of opposite angles. This is one pair of vertically opposite angles, and the other pair of vertically opposite angles is angle DOC and angle AOE. So I hope the concept of vertically opposite angles is now clear. Okay, that is all about the properties of angles. Now let's try to solve the problems from exercise 13. Exercise 13. I hope you can now see the problems, exercise 13 problems. I have increased the font so that you can see it clearly. Okay, let's solve the problems of exercise 13. The first one says that find the complement of each of the following angles. So we have to find, let's say the given angle is A equals to given to be 35 angle, and let's say complement of angle angle A, let be angle B. So this implies we must have, since the angles are complement, their addition should be equal to 90 degree. So we must have angle A plus angle B equals to 90 degree. Now angle AB is given to be one angle. We have to find the complement of angle 35. So we have assumed that the angle 35 be A and the complement of angle AB B. So we must have angle A plus angle B equals to 90 degree. This implies 35 degree and angle B equals 90 degree, and this implies angle B is equal to 90 degree minus 35 degree. This is equal to 55 degree. So 55 degree is the complement of angle 35. Okay. So we have to find the complement of all the angles. So for the rest of the problems, I'm not writing the solution in details. So I will have, let's say, I'm doing the solution in a more compact form. So let A equals to the given angle 47 degree, and I'm assuming that angle B is the complement of an angle A. So we must have angle A plus angle B equals 180 degree. This implies angle B will be equal to 180 degree minus angle A. This is 180 degree minus 47 degree. This is 133 degree. Now, if I do any calculation mistake, I am not really focusing on the calculation mistake. I might do some calculation mistakes. If you see any calculation mistake, please let me know in the comment section. I will appreciate that. So this is the angle 33 is the complement of angle 47. Now, similarly, 3, so I am writing it directly, as you can understand, that complement of angle 60 degree will be equal to 180 degree minus 60 degree. This is equal to, sorry, this is asking about complementary. So this will be 90 degree, not 180. The sum of complementary angles is 90 degree, not 180 degree. So this is 30. So this is 43 and 43, and this one 90 degree minus 60 degree, which is 30 degree. Similarly, part 4, complement of 73 degree is equal to 90 degree minus 73 degree. This is equal to 17 degree. Okay. Problem number 2 is asking to find the supplement of each of the following angles. Okay. So I'm writing the solution in a compact form. I'm not writing it in details as I did problem number 1, part 1. So we know that the supplementary angles, the addition is 180 degree. So supplement of angle 80 degree, this is part 1, of angle 80 degree will be equal to 180 degree minus 80 degree. This is equal to 100 degree. Similarly, part 2, supplement of 54 degree is equal to 180 degree minus 54 degree. This is 126 degree. Okay. Part 3, supplement of 105 degree is equal to 180 degree minus 105 degree. This is 75 degree. And part 4, supplement of 123 degree is equal to 180 degree minus 123 degree. This is 57 degree. Okay. Let's do question number 3. Question number 3 says, among two supplementary angles, the measure of the larger angle is 36 degree more than the measure of the smaller angle. Find their measures. Okay. So it is saying that the two angles are supplementary angles and the larger angle is 36 degree more than the smaller angle. So let larger angle be A and and smaller angle B, angle B. So this implies, we know that the angle A plus angle B should be equal to, since they are supplementary angles, they should be their sum should be equal to 180 degree. But we also know that it is said that the measure of the larger angle is 36 degree more than the measure of the smaller angle. So angle A, it is given that angle A is equal to the smaller angle. The larger angle is 36 degree more than the smaller angle. 36 degree more than the smaller angle. So we know that angle A will be angle B plus 36 degree, because we have assumed angle A to be the larger angle, angle B to be the smaller angle. So this implies we have angle B plus 36 degree plus angle B equals 180 degree. So this implies twice of angle B is equal to 180 degree minus 36 degree. This is equal to 144 degree. So this implies angle B is equal to 144 degree by 2, that is 72 degree. So the larger angle, angle A, is equal to, you can either solve A as angle smaller angle plus 36. So this is angle 72 plus 36, which is 108, or you can say that angle A is equal to 180 degree minus angle B, because they are, angle A and B are supplementary angles, their addition should be equal to 180 degree. Now, so this is equal to 180 degree minus angle B is 72 degree. So this is equal 108 degree. So 108 and 72 degrees are the angles. You just find their measures. Okay. Let's do problem number 4. It says that find the angle which is equal to its supplement. Find the angle which is equal to its supplement, meaning the angle is a supplement to itself. So let the angle be A. Now it is given that find the angle which is equal to its supplement. Let the angle be A. So now it's given that given angle A is supplement to itself, that is, itself means angle A. So this implies two angles are supplement to each other when the addition is 180 degree. So we will have angle A plus angle A equals 180 degree. This implies twice of angle A is equal to 180 degree. This implies angle A is equal to 180 degree by 2. This is 90 degree. So the angle is 90 degree and its supplement will obviously be 180 minus 90, that is 90. And so the angle 90 degree and its supplement are equal. Okay. Let's do problem number 5. Can two angles be supplementary if both of them are acute, obtuse, right angled? Can two angles be supplementary if both of them are acute? Now, acute angles means uh, what is an acute angle? Acute angle is uh, less than 90 degree. Acute angle is uh, less than 90 degree. So if let angle A and angle B be two acute angles. So this implies both angle A will be less than 90 degree and angle B will be less than 90 degree. If I consider this condition as 1 and this condition as 2, from 1 and 2 I can say from 1 plus 2, adding actually 1 and 2 condition, this is a relation angle A less than angle 90 degree and angle B is less than 90 degree. From 1 and 2, if we add these two, this is actually not equality, this is actually an inequality. From 1 plus 2 we can say that if angle A is less than 90 degree and angle B is less than 90 degree, we can say that angle A plus angle B is actually less than, we will have less than 90 degree plus 90 degree. This implies that angle A plus angle B is less than 180 degree. Hence, A plus angle A and angle B cannot be supplementary angles because the sum of two supplementary angles is 180 degree. And if the two angles are acute, then both angles are less than 90 degree and their addition will always be less than 180 degree. So acute angles, no. Two acute angles cannot be supplementary. Let's see obtuse. What is an obtuse angle? Obtuse angle, I guess. So okay. So just as a reference, what is an acute angle? You have let's say the line AB, and you have a point O, and if you an acute angle made on the line AB at the point O is something like this OC, and let's say this angle is this ray OD is vertical to the line AB. So we have angle BOD is equal to angle BOD is 90 degree and angle BOC is less than 90 degree. So angle BOC is an acute angle. Now for obtuse angle, I think the angle, what is an obtuse angle? I think obtuse angle is greater than 90 degree. Greater than 90 degree. So if we consider let angle A, angle B are two obtuse angle, this implies that angle A, since they both are obtuse angle A both will be greater than 90 degree, and also angle B will be greater than 90 degree. Let this condition be 1 and this condition be 1 and 2. So if we add the condition 1 and 2, if we add, we get that angle A plus angle B should be greater than 90 degree plus 90 degree. So this implies that angle A plus angle B is greater than 180 degree. But angle A and angle B must be equal to 180 degree. If they have to be supplementary angles, but if they are obtuse angles, they will never be supplementary angles because the sum of their angles will be greater than 180 degree. Okay. Part 3 is right angle. Of course, right angles. So it is given that right angle, if two angles are right angles, can they be supplementary? Right angle, what is right angle? We know that right angle is 90 degree. So over here we have angle, the two angles, let's say two angles are A is 90 degree and B is also 90 degree. So we have two angles, right angles A and B. So obviously they are equal to 90 degree. This implies the sum of their angles A plus B, angle A plus angle B will be 90 degree plus 90 degree. This is obviously equal to 180 degree, and so they can be supplementary angles. So two acute angles or two obtuse angles cannot be supplementary angles. Okay, let's do question number 6. In the given figure, so a figure is given. In the given figure, AOB is a straight line. Okay, so let's draw the figure. We have this figure. There is the line A, B. There is a point O, and there is a ray falling on the line at the point O, C, and we have AOB is a straight line and the ray OC stands on it. Okay, if angle AOC is 64 degree, this angle is given to be 64, and angle BOC, this angle is given to be x degree. Find the value of x. So we know that since ray OC stands on the line AB at point O, this implies the angle BOC and the angle AOC are linear pair of angles. So this is, in short, I am writing angles. So angle BOC and angle AOC are linear pair of angles. This implies linear pair of angles, their addition, sum of linear pair of angles is always 180 degree. So we must have angle BOC plus angle AOC equals to 180 degree. So this implies angle BOC is given to be x degree and angle AOC is given to be 64 degree. This is equal to 180 degree. So this implies x degree is equal to 180 degree minus 64 degree. This is equal to 116. So this implies x is equal to 116. It has asked to find the value of x. Now please remember, it has find the value of x. The value of x is 116. The value of x is not 116 degree, because it has already mentioned that the angle BOC is being referred as x degree. So x will be a integer or a number, which is 116. Okay, let's do problem number 17.7. Problem number 7 says, in the given figure, there is a figure. Okay, let's first draw the figure. There is a line AB, there is a line AB, there is a point O on the line, and there is a ray OC standing on the line line AB at O, point O, and the angles, it is given that in the given figure AOB is a straight line. Okay, AOB is a straight line. Actually, AOB is a, so AB is the straight line. Actually, it is trying to say that AB is the straight line, and ray OC stands on it. Okay, if angle AOB, angle AOC is given to be 2x minus 10 degree, and angle BOC is given to be 3x plus 20 degree. So this angle is 3x plus 20 degree, and this angle is given to be 2x minus 10 degree. Find the value of x. Also find angle AOC and angle BOC. Okay. Now the logic applies here is the same. We have the straight line AB and the ray OC is dropping or falling, standing on the line AB at the point O, which means that the two angles BOC and AOC are a linear pair of angles. A linear pair of angles. So I will simply copy paste this part of the logic. We will have duplicate. So we need this thing, same thing, that ray OC stands on the line, ray OC stands on the line AB at point O. This implies angle BOC and angle AOC are linear pair of angles. So this implies angle AOC plus angle BOC will be equal to 180 degree, since they are linear pair of angles, and the sum of linear pair of angles is always 180 degree. Now angle AOC is given in terms of x as 2x minus 10 degree, plus angle BOC is given in terms of x as 3x plus 10 degree. 3x plus 10 degree, and this is we have equal to 180 degree. Now on the left hand side we can always simplify the left hand side as 2x. We can open the bracket like this. We can write this whole degree is equal to 180 degree. Now we can get we can equate the value, the absolute value of the angles. Like if we have something like this, let's say y degree equals to 25 degree, this obviously means that y is 25. Y is not 25 degree, but y is 25. Similarly, we can say that 2x minus 10 plus 3x plus 10 equals 180. This implies if we if we add the like terms, x terms, and keep it the x terms to the left hand side and bring all the constants terms to the right hand side, we get 5x equals 180. So 10 cancels. So we get 5x equals to 180. This implies x equals 180 divided by 5. This is 36. X is not 36. Please mind it. X is not 36. X is not 36 degree, but x is 36. Now it has also asked to find angle AOC. So now angle AOC will be equal to 2x is 36 minus 10 degree. This is 72 minus 10 degree. This is 62 degree. And angle BOC, you can find angle BOC as 180 degree minus angle AOC. Since they are linear pair of angles, you can write 180 degree minus angle AOC. This is one way of solving angle BOC, which will be 180 degree minus 62 degree. This is equal to 818 degree. Angle BOC is 118 degree. Other way of solving the angle BOC is using the value of x. So angle BOC is given to be 3x plus 20 degree. So this is equal to 3x, x is 36 plus 20 degree. This is equal to 36 into 6 is 100. X is angle, what is angle AOC? 2x minus 10. X is 36. So 2x minus 10, 72 minus 10, 62 degree. So angle BOC is equal to 118 degree. And angle BOC will also be 3x20. Oh, sorry, I did a calculation mistake over here. This will not be 10, but this will be 20. And this will not be 10, this will be 20. So it will not actually cancel, but will not cancel. So it will be 180 minus 20 plus 10. So this implies this is equal to 170. This is equal to 170. This implies x equals to 170 divided by 5, which is 34. Now 34. So angle AOC will be 2 into 34 minus 10 degree, which is 68 minus 10 degree. So this is 58 degree. And angle BOC, the first way of solving angle BOC will be 58. This is 2, 58. So this is 122 degree. Now the other way of solving angle BOC is using the expression 3x plus 20. We know x is 34, so we have 3 into 34 plus 20. This is 102 plus 20 degree. This is 122 degree. So angle AOC is 58 degree, angle BOC is 122 degree, and x is 34. Okay, let's do problem number 8. Problem number 8 says in the given figure, AOB is a straight line and rays OC and OD stand on it. Okay, let's draw the figure first. We have the line AB, and there is a point O on the line, and we have rays OD falling on the line AB, the rays OD and the rays OC. Now it is given that the rays OC and OD stand on it. If angle AOC, it is given that angle AOC, this angle is 65 degree. Angle BOD, this angle is angle 70 degree, and angle COD means this angle is given to be x degree. So find the value of x. Now, okay, so AB. So we know that as per the given diagram, we know that rays OC and OD stand on the same side. Remember, it is on the same side. This is very important. Same side of the line AB at the point O. So we know that rays OC and OD stand on the same side of the line AB at the point O. So this implies angle BOD plus angle COD plus angle AOC should be equal to 180 degree. Why? We know that the sum of all angles on the same side of a line at a certain point is equal to 180 degree. So the angles over here which are formed, the angles BOD and angle COD and angles AOC are formed on the same side of the line AB, that is, in this example, in the upper side of the line AB at the same point O. So the sum must be equal to 180 degree. Now this implies angle BOD is given to be 70 degree, angle COD is given to be X degree, and angle AOC is given to be 65 degree. This we have, this must be equal to 180 degree. Now this implies we have 70 plus X plus 65 degree is equal to 180 degree. So this implies 70 plus X plus 65 is equal to 180. So now if we solve for X, we keep the X on the left hand side and bring the all constants to the right hand side. We get 180 minus 70 minus 65. This is 180 minus 135. This is 45. So X is 45. X is 45. Okay. Let's solve question number 9. Question number 9 says that in the given figure, okay, so let's draw the figure first. We have in the given figure two lines AB and CD intersect at a point O. Okay, so let's draw the line. CD, and the lines AB and the lines, this is line AB, they intersect at the point O. Okay, they intersect at the point O. Let's see what is given. If angle AOC is 42 degree, angle AOC, this angle is given to be 42 degree. Find the measure of each of the angles. We have to find AOD, we have to find BOD, and we have to find angle COB. Now, since AB and CD are two lines intersecting at the point O, So this implies angle AOC and angle BOD are vertically opposite angles. Angle AOC and angle BOD are vertically opposite angles, and also angle COB and angle AOD are vertically opposite angles. So this implies, we know that vertically opposite angles are equal. This implies that angle AOC should be equal to angle BOD. This implies that angle AOC is given to be 42 degree. So we get angle BOD to be equal to 42 degree. Now, okay. So this angle we have found to be 42 degree. Now, let's say now also we know that ray OB stands on the line CD at the point, I'm in short writing PT as point O. So this implies angle BOD and angle BOC are linear pair of angles. Angle BOD and BOC are linear pair of angles because the ray OB is standing on the line CD at the point O. So this implies, we know that the sum of the linear pair of angles is equal to 180 degree. So we must have angle BOD plus angle BOC equals 180 degree. Angle BOD we have already found to be 42 degree. So we have 42 degree plus angle BOC equals 180 degree. So we now have angle, therefore angle BOC is equal to 180 degree minus 42 degree. This is 138 degree. So angle BOC is 138 degree. Okay. Now this implies, we know that angle COB and angle AOD are vertically opposite angles. So we must have angle BOC and COB same angle. So angle AOD will be equal to angle BOC. So this is angle equal to 180 degree. So angle AOD is 138 degree. Angle AOD is 138 degree. So this is angle is also 138 degree. Okay. Let's do problem number 10. Problem number 10 says that in the given figure, two straight lines PQ and RS intersect at O. Okay, so first draw the figure. Two lines. This is the line RS. This is the line RS and PQ. So P use another line. They intersect at the point O. Two straight lines PQ and RS intersect at point O. If angle POS equals to 114 degree, angle POS, this angle is given to be 114 degrees centigrade. Find the measure of each of the angles. Okay, it's similar to It's similar to a problem number 9. It is asking angle POR. It is asking angle ROQ and the angle QOS. Okay, now the logic is that PQ and RS are lines intersecting at the point O. So this implies angle POS and angle ROQ are vertically opposite angles. Similarly, angle POR and angle QOS are vertically opposite angles. Now this implies angle ROQ is equal to angle POS, which is given to be equal to 114 degree. So angle ROQ is 114 degree. Now, okay. Now, ray OC, ray OS stands on the line PQ, at the point O. So this implies angle QOS and angle POS are linear pair of angles. So this implies angle QOS plus angle POS should be equal to 180 degree, because we know that the sum of two linear pair of angles is always 180 degree. Now this implies QOS we don't know, POS we know is 114 degree. So this implies QOS plus 114 degree is equal to 180 degree. So this implies angle QOS is equal to 180 degree minus 114 degree. This is equal to 56. This is equal to 66 degree. Angle QOS is equal to 60 degree, and we also know that QOS and ROP are vertically opposite angles. This implies angle POR is equal to angle QOS is equal to 60 degree. So angle QOS is 60 degree. This angle is 60 degree. Obviously, this angle will also be 60 degree. So QOS is equal to 60 degree and POR is equal to 60 degree. Okay. Let's do the last problem, which is problem number 11. Okay. In the given figure, rays OA, OB, and OC, rays OA, OB, OC, and OD are such that, and okay, so basically it has be around the point O, some angles are being formed with some using some rays. As we have already discussed, that we have to use some rays to form multiple angles around the point O. So the figure given is, we have this ray OA, this is the ray OA, and we have this ray OD, we have this ray OD, and we have this ray OB, and we have this ray OC. All these rays have the common point O. Now it is given that such that angle AOB is 56 degree, that is this angle is 56 degree, angle BOC is given to be 100 degree, sorry, angle BOC is 100 degree, angle COD, this angle is given to be X degree, and angle DOA, this angle is given to be 74 degree. So it is asking find the value of X. Now obviously rays OA, OB, OC, and OD are making angles around the point O, So this implies we must have angle AOB plus angle BOC. These are all the angles that has been formed around the point O. Angle COD plus angle DOA, all must be the sum of their angles, must be the sum of all angles around the point O is 360 degree. So we have this. Now angle AOB is given to be 56 degree. So 56 degree plus angle BOC is given to be 100 degree. Angle COD we have to find, that is X degree, and angle DOA is given to be 74 degree. We have this equals to 360 degree. Now we can simplify this equation as 56 plus, we can numerically add all the values of the degrees and equate to the right, that is we have this much degree equals to 360 degree. Now we can say that 56 plus 100 plus X plus 74 equals 360. This implies if we keep X and add all the constant terms on the left hand side, we get 56 plus 74 is 130. So we get 230 equals 360. This implies X equals 360 minus 230, that is equal to 130. X is 130. Okay, so this brings to an end of solving the exercise 13 on the chapter lines and angles. I do not think there is any more exercise on this chapter. If possible, I will try to prepare one practice test paper on whatever we studied today in this video on lines and angles. So I will prepare the test tomorrow, and I will solve it and upload the solving video tomorrow. After the practice test paper 1 on this chapter lines and angle, we will move on to the next chapter, which is parallel lines, or parallel lines, I guess. So I hope this video was beneficial to you. If so, then please like it, share it with your friends, and also once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So until the next video, take care and bye.